Lesson number 2 is side lengths. Let's click here to jump down to the interactive panel. We'll go across to number 2, which is side lengths, and we'll click play. Drag the line around to create a new unit circle. I'm just going to put the lesson speed down like that. Alright, drag it around like this, just like in the last lesson. Go ahead and rotate the log to 30 degrees by typing 30 into the box. Okay, 30. Nice. We're going to make a triangle using this log. Drag the purple button to the right to create another line. Alright, drag it like that. Nice, now drag it straight up. Okay. See how there's a triangle between the log and the lines we drew? Now, let's play another game. Help the frog get this food by typing in the angle, just like in the last level. Okay, so this one could be like, there's halfway there, so maybe like 50? It's a bit past halfway. Okay, what about like 60? Ah, nice. Oh no, the log has sunk. Okay, how's it going to get back to the lily pad now? Let's drag the button to the right to make another log for the frog. Okay, like that. And then drag it straight up to give him a path all the way back home. Okay. Can you see this triangle we made here? The log floated back to the surface. Nice. Try these next 3. Okay, this one, 180 would be here, so maybe like a little bit less than 180, like 160. Okay, what about like 150? Nice. Drag the purple button to the left. Okay. And now drag it up. Awesome. Let's do this next one. Okay, all the way down here, so 180 is there. Let's add on, looks like it's like halfway, so 180 plus 45, 225. Oh, nice. Okay, drag the purple button across. Drag it down. Super, try a negative angle for this one. Okay, so going back this way instead. Looks like it could be about halfway again. Let's try negative 45. Oh, okay, a little bit more. Like negative 50. Nice. Okay, and then drag this across. Drag it down. Nice. Great job. Now, what if we need to work out exactly how long to make these logs instead of just dragging them? For example, let's go for this food at 60 degrees again. So type in 60, okay. This time we're going to help the frog get back by typing in the lengths of the logs. Okay. We'll learn how to calculate that next, but for now I'll just tell you. The length of the first one is 0.5, so type it in. Okay, so now we're not going to drag the button across, we're just going to type in the length, so 0.5. Okay, cool. Awesome, the length of the second one is 0.87, so type that in. Okay, 0.87. Okay, cool. Nice, but yeah, how do we actually calculate these lengths ourselves? Let's look at an angle of 30. Type it in. Okay. Drag the purple button to make the triangle lines. Alright. And then drag it up. Okay. This is where the trigonometry comes in. Because the first line goes straight side to side, boing, boing, and the second one goes straight up and down, these triangles are all going to be right angle triangles. Don't know why there's a dot 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 there, but anyways. Which means we can use SOHCAHTOA on them. Okay, if you remember this from your previous stuff that you've learned, we have SOH, S-O-H, CAH, C-A-H, and then TOA, T-O-A. And these are relationships and formulas that we can use to work out different angles in the triangle and different side lengths in the triangle, as long as the triangle is a right angle triangle. Let's label the sides of our triangle. Drag the hypotenuse label onto the marked area on our triangle. So drag the hypotenuse over to here. Now drag the opposite side over, okay, over to here. Lastly, drag the adjacent side over, like that. Let's find the length of the horizontal line, so that one there. Seeing as it's the adjacent side, we could use CAH or TOA, but not SOH, because SOH doesn't have any A's in it, and we're looking for the A, so we need to have an A in it. And seeing as in the unit circle the radius is always 1, the radius is 1, and that's also the hypotenuse, so we know the length of the hypotenuse is also 1, so we can use CAH. We don't know what the opposite side is yet, and so we can't use TOA, we can't use tan, but we know what H is, so we can use cos or CAH. Type the CAH formula into the input box. For theta, you can just type in the word theta. Okay, so we're literally just copying this formula here, and so cos open bracket, and then for theta, just type in theta, and it makes the theta symbol. And then close the bracket equals A over H. Make sure you use capitals for those ones. If you get stuck on it, gets a bit too messed up, you can always just clear it. And then if you can't quite get the formatting right, you can use the hint to kind of see what we're supposed to type in. So cos theta equals, and then you can use blah, 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 blah. And then the answer here will also tell you exactly what to type in. But if it's still not quite working, you can always hit the skip button here and it'll put it in for you. Awesome. Now replace theta with the angle of our current triangle, which is 30. So we're using an angle of 30 degrees there. So let's come across to theta. Sometimes it can be hard to use the mouse to get exactly where you want to go in this. And so you can just get close to it, and then you can use the arrow keys to go left and right. So I'm going to use cos of 30, and that's all I can do. Maybe I know what the H is, so I could replace that, but we're not supposed to do that in this step. We can do that in the next step. So for now, I'm just going to press enter. Nice. Now replace H with the length of our hypotenuse, which is 1. Okay, I'm going to click over here, and then I think it's not quite on the bottom of the fraction. I'm going to use the arrow keys to go left there, and then now I know I'm on the H, so I can backspace and replace it with 1. Great. Now what happens when we divide something by 1? Absolutely nothing. For example, 5 divided by 1 is 5, 125 divided by 1 is 125. So A divided by 1 is just A, so we can write cos 30 equals A. We don't need to have over 1 here. It'll just be the same as just A. Super. So the length of the adjacent side is just cos 30, which we can just put into a calculator. Put cos 30 into a calculator and type in the result, round to 2 decimal places. So put it in the calculator. It's going to be 0.87. Nice. So the length of the horizontal side is 0.87, and we found it using cos theta. Okay. Awesome, we're halfway there. Now for the vertical line. Let's check our SOHCAHTOA formulas again. It's the opposite side, so we could use SOH or TOA, but not CAH. So CAH has AH, but we want to have an O involved, so we can't use CAH. And we just worked out the length of the adjacent side, so we could use that. But in the unit circle, the hypotenuse is always 1, which is a very easy number to work with. So we could use TOA, right? Because we know the angle of theta is 30, and we know the opposite length. Well, we don't know that, but we want to know it, so that's good. And we know what the adjacent is. We know the adjacent is 0.87. But a couple things. If we use sine instead, we have an H in the bottom, which is just 1 for the unit circle, so that makes it way easier. Also the A, it's not exactly 0.87. We had to round it to get that. And so we either have to use the exact number, which is going to be a lot of annoying decimals, and even then it's it's not quite accurate, or we're going to have to use 0.87 and then it's going to have a rounding error. So we almost always use so or car in the unit circle. Let's just use so here. So if we're getting these side lengths here, the adjacent and the opposite, we're going to use just so or car. We're not going to try and use toa on them. We'll talk about tan and toa in the next few lessons. But yeah, for these side lengths here, we could technically use tan, but we're not going to. It's much easier to just use the hypotenuse, which has a length of 1. Type the so formula into the input box. Remember, you can just type in theta for theta. So sine theta equals O over H. Make sure you use capitals. And replace theta with the angle of our current triangle, which is 30. Okay, I'm going to click here and then use the arrow key. 30. Replace H with 1. It's 1. And remember, when you divide something by 1, nothing happens. So we can just get rid of the 1 and the fraction line and just have sine 30 equals O. Okay. O divided by 1 is just O. So you can just do that. Super. So the length of the opposite side is just sine 30, which we can put into a calculator. So put sine 30 into a calculator and type in the result. It's going to be 0.5. Nice. So the length of the vertical side is 0.5, and we found it using sine theta. Okay. And a short note here, 0.87 is like almost 1. And so it makes sense, right? Because the radius of the circle is 1. So it makes sense that that would be out here and almost be 1. And as for the 0.5, we can't quite see the top of the circle, but it only goes halfway to the top of the circle, which makes sense because 0.5 is half of 1. Okay, well, we can have a look here then. So 0.5 goes halfway up. If we go another 0.5, we get all the way up to 1, which is the top of the circle. So that's how we can kind of envision these numbers. Like we said, in the unit circle, the hypotenuse is always 1, so it will always cancel from the so and car formulas. So remember how we had like O over H, but then the H was just 1, so it went away? That always happens in the unit circle if we're using the hypotenuse, because it's always 1. So the adjacent or horizontal side can always be found using cos theta, and the opposite or vertical side can always be found using sine theta. Let's use those skills to help feed the frog again. First, find the angle for this one. All right, we're almost at 90, so why don't we try like 80? Nice. The angle is 80, so we can find the length of the adjacent horizontal log using cos 80. Put it into a calculator and type it in, rounding to 2 decimals. Okay, got my calculator here. So cos 80, 0.17, if I round it to 2 decimals. Oops. Let's type that here, 0.17. Nice. And we can find the length of the opposite or vertical log using sine 80. Put it into a calculator. Sine 80, 0.98. Nice. Try the next ones by yourself. Okay, this one's a pretty small angle, maybe like 20. Nice. Okay, so find the horizontal length. That will be cos of 20, which is 0.94. And the vertical length would be sine of 20. So 0.34. Okay, this one kind of looks like 80 again. Let's try 80. Maybe like 75. Nice. Okay, find the horizontal length. Okay, that would be cos of 75. 0.26. Find the vertical length. All right, that would be sine of 75. 0.97. Okay, this one Looks like halfway. So half of 90 is 45. Yeah, perfect. And the horizontal length will be cos of 45. So 0.71. The vertical length will just be sine of 45, which is also 0.71. Okay, last one. Oh, tiny angle again. Is it 20 again? No, okay. 15? Nice. And the horizontal length is 0.97, because we did cos 15. Okay, cos 15, 0.97. And vertical length would be sine 15, which is 0.26. Awesome stuff. You might have noticed that all of those angles were in this section. Okay, that section there. We'll learn how to apply this stuff to the other three sections in the next lesson. Okay, so 2, 3, and the fourth section. For now, Mr. Frog is tired after all that. Let's let him sleep. Okay, so we did side length size, side length value, and using cos theta and sine theta. And we unlocked level 3. Okay, jump down here to the practice questions. Remember, you can, if you're confused on what the question's even asking, you have the video explanation here you can go through, and then you can try it yourself. And when you finish that, tick off this lesson here and move on to the next one, which is symmetry.